Some real-life situations are examples of using arrangements. For example, how many ways can we seat a family of 6 people, a mother, father and 4 children, at a dining table, with 1 at each end and 2 along each side, if 1. Anyone may sit at any seat, or 2. The 2 parents must be seated 1 at each end of the table. Let's look at part 1 first, and let's draw a rough diagram of what's going on. And we can give each seat a different colour to help us understand the situation. And we have a mother, father and 4 children. Let's call them A, B, C and D. So those are our 6 people in the family. And we want to seat them at this table, and anyone may sit at any seat. So we're doing part 1 first. So we can start at any seat, make a choice and then do the same for any other seat, and keep doing that until all 6 seats are occupied. Let's start with the red seat. The key thing is, how many choices do we have at this stage? Well, we have 6 people in the family, and we can seat any one of those at that seat, so really we have 6 choices. Let's write that in. We can go to any other seat now, doesn't really matter, might as well do it a little bit methodically, so let's go to the orange seat. Now how many choices do we have? Well, imagine we've chosen the father to be at the red seat, and now we're going to the orange seat. We can choose any of the 5 remaining people. So it could be one of the children at the orange seat. It doesn't really matter. Now let's go to the yellow seat. How many choices do we have? We've got 4 choices remaining. For example, we could put the mother on the yellow seat. And now the green seat. How many choices do we have? Well, we can put in A, C or D. We can put any of those at this seat. So we have 3 choices. So let's say we put D in that one. And now for the blue seat, we've got 2 choices. Let's say for example C. And finally for the purple seat, we only have 1 choice. We've only 1 person left, so we have 1 choice. So 1 choice here. So we can see that we had 6 choices, 5, 4, 3, 2 and 1. So as usual we multiply them. 6 by 5 by 4 by 3 by 2 by 1, or in fact we could say 6 factorial, and that's 720. So there's 720 different arrangements we could make in that simple scenario. We don't really have to draw out a table and different coloured seats, but in this scenario it does help. We could just draw this out as 6 different slots. Again, just for this example we're going to use different colours. We don't really have to. So we have 6 different decisions to make. So for the first decision we have 6 choices. Then for the second it's 5, 4, 3, 2 and 1. And we multiply them. So we could do it out like that if we wish. And remember, it doesn't really matter which seat we decide to fill first. So we could do this in a completely different order. So we could start with the yellow seat. How many choices do we have? 6. And then the blue seat, we've got 5 remaining choices. 4, 3, 2 and 1 again. So in any case, it's still going to come out as 720. So with no restrictions, we've got a lot of arrangements or permutations in this scenario. Let's look at the second scenario. So in part 2, the 2 parents must be seated 1 at each end of the table. So let's draw the diagram again. We've got mother, father and 4 children. We're going to call them A, B, C and D. So we always start with the slots that have a restriction on them. The 2 parents must be seated 1 at each end of the table, so the red seat and the green seat, we need to tackle these first. So how many choices do we have for the red seat? Either the mother or the father can sit at this seat, so we have 2 choices. So for example, the mother could be seated at the red seat. Now we need to deal with the green seat. Either the mother or the father must sit here. The mother is already seated, so it's got to be the father. We have 1 choice. So now the remaining seats, we can put any of the children at any of these seats. So let's look at the orange seat. We could have any one of the 4 children. So let's say B. For the yellow seat we've got 3 remaining children. Let's say C sits there. For the blue seat, 2 remaining children. we could pick A, and for the purple seat, got one choice. So if we start at the red seat and go clockwise, we have two choices by 4, by 3, by 1, by 2, by 1. If you multiply that out, you get 48. So we have 48 choices now. We had 720 different arrangements when we had no restrictions. As we get used to these kinds of questions, we don't really have to use different colours. We can just say, well, there are 6 slots, 6 different seats, and we can indicate the two ends of the table by having a double line or something like that. And now we know we're choosing among 6 different people, and we know that these 2 slots are the restrictive ones, so we must deal with them first. So for the first one, we must choose among 2 parents, so we've only 2 choices, and here we must choose among 1 remaining parent, so we have 1 choice. And for the other ones, we must choose among 4 children, 3, 2, and 1. And we multiply, we get 48. So we don't really need to use all the different colours. It's just helpful for us to visualize it when we're learning it.